Good evening, everyone. You are welcome to our class today. I hope you're doing great this evening. So we are going to get to business in order to cover our class up on hydrogen like we scheduled. I hope that at the end of this class, perhaps much later, I'll just give you some few minutes so that we would still kick off another live class where I will quiz you, all right, from your professional exam buddies on the kind of problems or questions that they can say when you are dealing with hydrogen gas. So without wasting time, let's get to business. I'm going to project the board now and we look at the properties and uses of hydrogen. Properties and uses of hydrogen. So, you are welcome to this class on preparation of hydrogen. Today, we are going to give attention to the properties of hydrogen. Like I told you guys, we'll be giving attention to properties of hydrogen. And when you talk about properties of substances, we give attention to the physical properties, and we also give attention to the chemical properties. So we will be studying the physical property and the chemical properties of hydrogen right away, okay? We will be studying the physical properties and the chemical properties of hydrogen. And of course, we're going to get to business. What are some physical properties of hydrogen that you are expected to know? So we're going to list them. I hope you have your writing materials with you. I'll be checking the network situation to make sure that we are not caught off guard. And remember to share the link to your friends. Okay, send it to them directly. Invite them to join the class right away. It's going to be a quick class. Physical properties of hydrogen. One of the physical properties of hydrogen that you should know is that hydrogen is a colorless and odorless gas. Hydrogen is what? A colorless and odorless gas. Although someone will talk about tasteless gas as well, it is not always ideal and not advisable to taste chemical substances. Are you following, right? Yeah, it's not ideal. It's not advisable to test chemical substances. All right, so I'm using this to monitor you people network. You said Israel Jesse, network is disturbing you. Please, once network is disturbing, immediately let me know. I don't want any stress that we spend time and of course nothing is happening. So I'll be tracking what is happening there. Jesse, is network okay at your end? Because I can see that network is okay here. Okay, network is okay here. All right, like I mentioned, one of the physical properties of hydrogen is that it is a colorless gas and it is odorless. The concept of tasteless, let's leave that for now. I hope you've written that, right? It's colorless and it is odorless. Property number 2 is that hydrogen is neutral to moist litmus. Hydrogen is what? Neutral to moist litmus, which means if you expose litmus paper to hydrogen will not affect it. Let me show you, litmus paper that I've got here. This is blue litmus paper. This is blue litmus paper. You can see that. You can see this. This is blue litmus paper, right? So if you damp it, if you moist it and you put it, let me just bring out this one. If you moist it and you put it inside, let's say a test tube of hydrogen, there will be no effect. Hydrogen won't change any of the litmus paper to another color. It won't change the color. In our discussion of acid, base, and salt, you know that an acidic substance will change this blue to red. An acidic substance will change this blue to red, and a basic substance will change this red to blue. But hydrogen won't do that. That tells us that hydrogen is a neutral gas. Hydrogen is what? A neutral gas. Because if hydrogen is going to affect litmus, hydrogen does not. Okay? If you If you dip a moist litmus paper into hydrogen gas, there will be no effect. Take note of that. So we've mentioned two properties, okay? Then hydrogen is lighter than air, right? So we say that it is less dense than air. As a matter of fact, hydrogen is one of the known lightest element. Hydrogen is one of the known what? Lightest element. Are you following, right? It is about 14.4 times less dense. It is 14.4 times less dense than air. No wonder when we're preparing hydrogen, we stated that hydrogen is collected by downward displacement of water, which means that the hydrogen goes up. Are you following, right? The hydrogen does what? Goes up. And then displaces water downward. Because hydrogen is lighter, right, than air. That happens. It will always move up. Does that make sense? So I've mentioned three physical properties of hydrogen. First, it is colorless, it is odorless. So we should leave the concept of tasteless. Yeah, even if it doesn't have taste, but it's not ideal to taste chemical substances, all right? Or you just may not know what you're exposing yourself to. Then number two, I stated that hydrogen is neutral to litmus. It does not affect litmus paper. I've mentioned that. And then number three, I explained that it is lighter than air, less dense than air. It is about 14.4 times less dense than air. And I stated that hydrogen is one of the lightest known elements known so far. Let us talk about physical property number 4. There we are going to look at the concept of the solubility of hydrogen. Does hydrogen dissolve in water, right? So we say that hydrogen is relatively soluble. Just a little quantity of it is soluble. For example, if you have water and you have to dissolve hydrogen, you could just have, there are about 2 cubic centimeters of hydrogen dissolving in there about 100 cubic centimeters of water. So you can see that the amount of volume of hydrogen that can dissolve in water is very small. Are you following, right? So it simply tells us that hydrogen is not so much soluble in water. It's not. Just relatively. Very small, soluble in water. Okay, so we use the term that hydrogen is relatively soluble in water. That is property number what? 4 that you expected to know. Okay, then in terms of the boiling point, hydrogen has a low boiling point. Hydrogen has what? Low boiling point. You want to take note of that. The value of its boiling point is not important to your examiner. The value of the boiling point of hydrogen is not important to your examiner. It's there about minus 253 degrees centigrade. Minus 253 degrees centigrade. But like I said, your examiner is really not interested in you getting to know this boiling point of hydrogen. Just know that hydrogen has a very low boiling point. That is sufficient. Now we have analyzed the physical properties of hydrogen. In summary, we considered the color, we considered the odor of hydrogen, and we stated that it is colorless. So let me put less here. We'll say that it is what? Odorless. Let me put less there. Are you following, right? Hydrogen does not have color and it doesn't have odor. We went ahead to talk about the effect that hydrogen will have on litmus paper. The effect that hydrogen will have on litmus paper. So effect on litmus, we talked about that, and we said that with respect to litmus, hydrogen is what? Neutral. So hydrogen is an example of a neutral gas. Take note, because the examiner can ask you this question: which of the following is a neutral gas? When you're asked that question, it simply means which of the following gases will not affect litmus, will not change the color. So imagine I give you something like carbon dioxide, I give you something like hydrogen chloride, I give you something like sulfur oxide, and I give you hydrogen gas. In fact, just imagine I give you chlorine gas. Chlorine gas, to an extent, is acidic. It's an acidic gas. So imagine I even give you chlorine gas in that option, and then I give you hydrogen gas. And my question is, which of them is neutral to litmus paper? The correct answer is hydrogen gas. It is neutral. Quickly, let us look at, okay, we also talked about the concept of its density. density of hydrogen, right? We try to compare the density of hydrogen to that of air. And we stated that hydrogen is less dense than air. It is less dense than air. Okay, less dense than air. So you want to take note of this. I try to go ahead to quote by what value it is less denser than air. They're about 14.4 times less dense than air. And then I mentioned under this concept that hydrogen is the lightest known metal. Hydrogen gas is the lightest known metal. Lightest known metal. Lightest known metal. So you take note of that. No wonder it is used in filling balloon. No wonder hydrogen is used in what? Filling balloon. Good evening, everyone. Joe Ella, good evening. You're welcome to join the class. Okay, Mrs. Ifezwe, good evening. You're welcome. I can see all of your signatures. You're all welcome to the class. Rejoice, you're welcome. All right, let's move on. Let's move on. We talked about the solubility of hydrogen as well. So, and I explained that hydrogen is quite less soluble in water. Yeah, solubility. It is quite less soluble in water. I gave the part in terms of volume of hydrogen that can dissolve in water as little as 2 centimeter cube in 100 cubic centimeter of water. So it is relatively soluble in water, just a little. So we can't really consider it as very much soluble. It is not. And no wonder in the preparation of hydrogen, we found out that the hydrogen gas went up while water was displaced what? Downward. Remember in our previous class, preparation of hydrogen. Now, let us shift our attention to chemical properties of hydrogen. These ones that I listed here are the physical properties of hydrogen. Of course, when you talk about physical, that is without chemical reaction. You just look at it, you can say some things about it, the physical nature. Chemical properties of hydrogen, we want to talk about it, okay? Chemical properties. Now, the first chemical property we are going to give attention to is the fact that hydrogen form both ionic and covalent compounds with some substances. Chemical property number 1. Chemical properties. Now we are done with physical properties. If you wish to screenshot this, you can screenshot. Okay, if you wish to screenshot this, you can screenshot so that I wipe the board, because we are looking at the concept of chemical properties now, right? So I'll be wiping this, please. Next, we want to discuss the chemical properties of hydrogen. Please take notes after this class, because this class is not going to take time. We're almost done. We're just looking at the properties and then the uses. That's all. I'm going to host another class immediately. Yeah, I'll host another class where we are now going to answer questions based on everything that we've covered on hydrogen so far. Like I told you guys from our physical class, we've got questions to answer on hydrogen while dealing with non-metals, right? So make sure you stay around. Remember, like I said, there is no time. Okay, this is the 24th hour to your exam. The exam is pulling strength and coming. You have just exactly 1 month to the kickoff of the exam, I guess so. So make sure you utilize all of the opportunities you have to learn. Chemical properties. Chemical properties of hydrogen. So the first chemical property I want us to give attention to is that hydrogen forms both ionic compounds and covalent compounds with metals and non-metals. 1. Hydrogen forms ionic compound. Permit me to abbreviate that compound. Ionic compound with metals, and covalent compounds with non-metals, covalent compound with non-metals. So what do we mean here? If hydrogen reacts under chemical combination, if it reacts with metals, the bonding, the type of bonding there is ionic bonding. The reason, if hydrogen is reacting with metals, that hydrogen will be behaving as non-metal. Remember I told you something, in our previous class, I guess, and even from our physical class, that hydrogen can be placed in group 1 or in group 7 because, yes, it has 1 electron and in its outermost shell. And if any substance has, say an element has 1 or 2 or 3 electrons in its outermost shell, we usually classify that element under metals because metals are known to have valence electron of 1, 2, or what? 3. I hope you're following, right? No wonder hydrogen is placed in group 1. But hey, come to think about it. There are a lot of things we study about metals that we don't classify hydrogen under it. So you now see that hydrogen, although being placed in group 1 for convenience, can also be in group 7. It can be in group 7 because it has these non-metallic properties. And I will explain. If you come to group 7 of the periodic table, for example, group 7, the halogens. Now we know then that these guys, they need 1 electron to complete their outermost shell. They need 1 electron to complete their what? Outermost shell. Now look at hydrogen. Look at hydrogen. How many electrons does hydrogen need to complete its outermost shell? How many? Hydrogen needs 1. Hydrogen needs what? 1 electron to complete its outermost shell. All right? And because hydrogen needs 1 electron to complete its outermost shell, then it can conveniently be placed in group 7 because it has that behavior. And again, hydrogen undergoes covalent combination. Yes, like I mentioned. So if hydrogen can combine covalently, covalent bonding is a property of elements that are non-metallic. So you can see that hydrogen has that dual behavior. Okay. I also want to point to the concept of the oxidation number of hydrogen. Oxidation number of hydrogen can be positive 1. Usually we see it as positive. By the way, let me mention this quickly before it happens. You know, I am using the EWT destruction company or what. EDC or whatever they call themselves. And of course, I've never trusted these people, this company, because they can mess up a lot, can misbehave. So in case it goes dark, just be patient. Of course, I will light up the classroom. I'll put on the generator so that the class continues. But they have just done so. They've just been bringing and taking. EWT destruction company. Let's continue, please. Hydrogen can exist with positive valency. In that case, hydrogen is reacting with metals. So, right? Oh no. In that case, hydrogen is expected to react with non-metals. So it has this partial positive polarity as if it lost electron. Actually, it doesn't lose electron. What hydrogen does, like in our physical class, I treated the concept of covalent bond. When hydrogen reacted with chlorine, you notice that what happened there was sharing of electrons. Sharing of electrons. Hydrogen donates 1. Something like chlorine will donate that 1 unpaired electron in its outermost shell. Then they will share it equally. And I remember, you know, you see something like this. The electron of hydrogen will be donated. Then chlorine will also donate 1 of its electron. Let's have this, showing the Lewis dot structure of chlorine. You have something of this kind. So this is what happens. When hydrogen is combined with something like chlorine, non-metal, that hydrogen in that case is also behaving as non-metal. That's the funny thing. Yes, although you see hydrogen written with H plus here, what actually happened is that hydrogen has this partial positive polarity, while chlorine will have partial negative polarity, which, like I mentioned in our physical class, when I treated chemical combination, that hydrogen chloride is a polar compound. It has positive end and negative end. This electron that is being shared is closer to chlorine because chlorine is considered highly electronegative. It has this stronger effect in pulling the shared pair electron to itself. That is why it seems as if hydrogen is now positive somehow there. Okay? But now when hydrogen is reacting with metals, what happens? There, hydrogen will kind of collect totally the electron that the metal has. And the valency of hydrogen in that case would be -1. So you take note of that. the oxidation number of hydrogen there will be negative. So you want to be aware of this. Anytime hydrogen is reacting with metals, it behaves completely as non-metal, and then it will have oxidation number of valency of -1. But if it is combining with non-metal, it will have this positive polarity. Are you following, right? Yeah. So in the case of this hydrogen having negative polarity, you can think of when hydrogen reacts with sodium, you have this sodium hydride, a strong reducing agent. Yeah, sodium hydride is a reducing agent. In our physical class today, we treated redox reaction, types of reaction. I took my time to explain that concept. Okay. And of course, you see, in this case, the valency of hydrogen here is -1. Take note, it's minus has combined with what? Sodium. And of course, the type of bonding here is ionic bonding. It's ionic bonding because sodium will totally transfer its valence electron of 1 to hydrogen. Are you getting me? To transfer it. So this is one chemical reaction of hydrogen. You want to take note of this. Quickly, let me show you the chemical reaction. First, when hydrogen reacts metals like sodium, you have something like this. This is solid, this is gas. And then of course we have our product, sodium hydride. Sodium hydride is a strong reducing agent. Okay, it's a reducing agent. And of course, to balance up this, we have to put our 2 molecules here because the valency of sodium is 1. Valency of hydrogen is also 1. The only thing is that sodium here is +1. Hydrogen is what? -1. Since they have the same valencies, whatever the atomicity of sodium is, that is the same atomicity that hydrogen will have. You can see them here 1, 1. So coming in the reactant, since hydrogen is 2, if both of them combine in balancing it, you're going to put 2 molecules. You cannot write sodium hydride this way. It's wrong to write it this way. This is not correct. Sodium hydride is just NaH. So if you're not considering balancing, because hydrogen here is a gas, all I have to do is to put 2 molecules. Therefore, I'll come over here and introduce 2 molecules to the sodium. We are done with this. What would happen if hydrogen peroxide freezes? We are not treating that concept yet. Under oxygen and its compound, we will treat that. Extreme 360H5H. Under oxygen, we'll treat peroxide, and then we'll learn what happens in that case. All right. For one thing, I want to maintain the status quo of what we are learning. We are treating hydrogen and its compound. Of course, in hydrogen peroxide, hydrogen reacts with, combines with oxygen, you have H2O2. But we shall treat that under oxygen and its compound. That's where peroxide comes in. Now let's look at the next reaction where hydrogen combines with non-metals. If hydrogen combines with non-metals, you have the reaction will go this way. Let's look at something like hydrogen combining with sulfur, hydrogen gas combining with sulfur. Sulfur is solid. And so let us see what is going to happen. This is going to give us H2S. This is the correct chemical formula of sulfur. You have problem with how to write the correct chemical formula of a compound. Like I said, the knowledge of atomic structure and valency is going to help you. And that I have covered 100% on this channel. Make use of what is available for you on this channel. So this is hydrogen sulfide. It's a gas. Okay. And of course, this is balanced. You see, in this reaction, hydrogen is combining with this sulfur. This reaction is covalent in nature. It's covalent. Why this one is ionic? This is one chemical property of hydrogen. Number 2 chemical property of hydrogen, we are going to deal with combination reaction. Of course, this reaction I showed you on the board is also combination reaction anyway. This reaction I showed on the board is also what I said, combination reaction. Remember, like today we treated types of reaction. One of them is combination reaction, you know. You have it in your note, you can check. We have thermal reaction, we have decomposition reaction, double decomposition reaction, reversible reaction, redox reaction. You know, you can mention them as we learned today. Displacement reaction. Combination, where when you add 2 elements directly, when you combine them. So hydrogen undergoes combination reaction. I've just shown you this one. This one is also combination reaction as well too. So that is it, okay? That is it. Hydrogen also acts as a reducing agent. That's another chemical property you want to take note of. Chemical property number 3, as a reducing agent. As a reducing agent. I am very happy that today we treated the concept of redox reaction, reduction, and oxidation. So when you hear about hydrogen act as a reducing agent, okay, that I believe should make sense to you. If hydrogen is a reducing agent, what does it cause in a reaction? It causes reduction. It causes what? Reduction, which means it can add electron to something. Hydrogen can do what? Add electron to something. You know, when something gains electron, it is reduction process. Reduction is gain of electron. So if hydrogen acts as a reducing agent, it means that hydrogen has this ability of giving you electron, and if you receive the electron, you have gained electron. What hydrogen has done to you is simple. Hydrogen has succeeded to reduce you. Hydrogen has caused reduction to you. So hydrogen is a reducing agent. And how do we know that? Quickly, we are going to consider some reaction. Hydrogen can reduce oxides of copper. It can reduce oxides of what? Copper. Like if I have copper oxide, hydrogen can react with it and act as a reducing agent to reduce that what? Copper oxide. What about iron 3 oxide? Hydrogen can also reduce iron 3 oxide to iron. It can reduce copper oxide to copper. Let us take a look at the chemical reaction of that. Imagine that I have copper oxide. This is copper 2 oxide reacting with hydrogen gas. This is a solid. So you have the gas there. So what happens? Now watch what is going to happen. Hydrogen is going to react with this. If you pass this hydrogen gas through this stream, that is hydrogen gas through this solid, this hydrogen will pick this oxygen from there. Remember that reduction can also be defined as removal of oxygen or addition of hydrogen. So if you are reacting with hydrogen now and hydrogen gives you 1 electron, it has reduced you. Or it gives you hydrogen. Hydrogen gives you hydrogen, so it gives you itself. It has reduced you. Or if you have oxygen, and then hydrogen removes that oxygen from you, hydrogen has reduced you. So in this case, hydrogen is going to remove this oxygen, and then you have H2O liquid, then the copper will be deposited as a solid. So what hydrogen has succeeded to do here is to reduce this copper oxide. If you check the oxidation number of copper here, it's going to be +2. But here, the oxidation number of copper is 0 because it's just an element. Here it is +2. You can find out. We've learned how to calculate oxidation number already. So you notice that the oxidation number of copper here reduced from +2 to 0. And when oxidation number reduces, what is happening to that guy? Reduction. Because reduction, in terms of electron, is gain in electron. And when you gain electron, your oxidation number will do what? Reduce. This is a good example of hydrogen acting as a reducing agent. Let us look at another one. I mentioned iron 2 oxide, iron 3 oxide rather, iron 3 oxide. If you react it with hydrogen gas, iron 3 oxide, what is going to happen? This hydrogen will pick this oxygen as usual, and then it's going to give us water. It's going to give us H2O, and then this ion will be given off as a solid. It will be deposited. One can balance up this reaction. Ion in the reactant. Let me check the network situation, please. All right. I think we are still following through. The network here is okay. The network here is okay. Remember to share the link to this class to your friends directly. Invite them to join. And when you join, you're asking questions on this, please ask specifically based on hydrogen directly. Okay, that would be appreciated. Because I cannot jump from this topic I'm teaching and dealing with something else. That's not right, okay? So let us balance this. Ion is 2 in the reactant. So normally or ordinarily I'll have to come and fix 2 molecules here. And then oxygen is 3 here. If oxygen is 3, I have to come and fix 3 here to make this oxygen 3. Let's do that and see. So this is 2 molecules of iron, then 3 molecules of water in order to cover up for this oxygen that you have here. You now notice that in the product side, hydrogen becomes 6. So come to the reactant, hydrogen is 2 here. What can you multiply 2 by in order to get 6? If you multiply 2 by 3, you get 6. It means that to balance up this hydrogen, I'm going to fix 3 here. This reaction shows the reducing action of hydrogen. Hydrogen is a good reducing agent. And these are the various chemical properties of hydrogen that you're expected to know. Please, you can screenshot this if you have not copied it, right? Because I'll be wiping the board right away. Do so. Let me wipe and then we move on. For which exam? All right. This is in preparation for a Nigerian professional exam that prepares our students for higher institution. All right. The examination name is called University Tertiary and Matriculation Examination, UTME. The exam is conducted by a body called JAMB, Joint Admission and Matriculation Board. Okay, we are done with this, and I hope you screenshot this explanation that you have on the board. There are 3 chemical properties I have covered for hydrogen, and it's sufficient. Not much chemical property of hydrogen as it is. So we are done with that. If you have hydrides of hydrogen, and it dissolves in water, okay, it's going to give you hydroxide. For example, calcium hydride. Calcium hydride is CaH2. If you react it with water, H2O, it's going to give you calcium hydroxide, and hydrogen gas will be given off. Oh, I am from India. I am preparing for JEE. You might know we also have hydrogen chapter in chemistry. Yes. You know, one good thing about all this concept of science is that it is universal, okay? So our friend from India, VVS Creation 7640, you can also learn wonderfully well from this class, okay, while you prepare for your JEE exam there in India. Jennifer Arinze, you're welcome to join the class. I'll see your signature. Now, let us move on to another concept of hydrogen. We are going to study tests for hydrogen. How can you test that hydrogen is present in a given substance, in a given sample, or hydrogen is present somewhere, right? How do you test for the presence of hydrogen? I'm going to wipe the board now. I'm going to wipe the board. We are looking at tests for hydrogen. We are done with the properties of hydrogen. Quickly, the test for hydrogen. Test for hydrogen. Test for hydrogen. One good thing known about hydrogen is the pop sound that we hear when you bring a lighted splinter, right, close to where hydrogen is found. The hydrogen gas, right, will make, you're going to hear a sound. That sound is a pop sound, right? Pop. And then you know that hydrogen is present. Test for hydrogen. Test for hydrogen. Test for hydrogen. Are you there? So I'm going to be just very straightforward. There is no 2 ways to that. Let us assume that this is a test tube. And then this test tube, let's say it contains hydrogen. Let's say it contains hydrogen gas. Let's say it contains hydrogen gas. Okay? Now, if you insert a lighted splinter into it, are you following, right? Splinter could just be like, maybe if I have a wood and I'm able to peel off a piece, are you following, right, of the wood? I'm able to do what? Pull it off. And then I light that wood. That piece of wood that I peeled off. There are this type of wood that has that, is it plywood? You can peel off some part of it. So if you light it and then you decide, or you put it into a test tube containing hydrogen, you're going to hear a pop sound. You're going to hear what? A pop sound. That pop sound indicates that hydrogen is present. That pop sound indicates that hydrogen is what? Present. Like I said, you have a lighted splinter here, right? Let me say that this is a lighted splinter. So this is a lighted splinter. Lighted splinter. Okay, so you lit it and you put it into the test tube containing hydrogen. A pop sound indicates, so this is just like result, the result you're expecting. A pop sound indicates presence of hydrogen. Indicate presence of hydrogen. When you are running these experiments, you use just a little amount of hydrogen, please. Use what? Just a little amount of hydrogen. Don't use large amount of hydrogen. Are you following, right? So when you light that splinter, put it in a test tube. If that test tube contains hydrogen, the lightest splinter will burn. It will burn more with a pop sound. Pop. Note. So that pop sound is one key thing we use to identify the presence of what? Hydrogen. I hope you're together, right? Let us now talk about the uses of hydrogen. Let us look at uses of hydrogen. After this, I am going to draw something. And what I am going to draw, I tell you that examiners can also test you on it. And then they would request you to identify the gas that is present in each test tube. Are you following, right? To indicate whether hydrogen is present or not. Desmond, this is... Good evening, everyone. You're welcome to join the class. I hope the network is stable at your end. So far, it's cool with me here. It's cool with me here. So, uses of hydrogen. One use of hydrogen is it is used in the manufacture of ammonia. You use it to manufacture ammonia. You want to take note of that. Is one uses of hydrogen. It is used in manufacturing hydrochloric acid. It is used in manufacturing what? Hydrochloric acid. You can also use it in manufacturing methanol. You can use it in manufacturing what? Methanol. There are actually other things you use hydrogen to manufacture, but we spot out these ones, okay? Ammonia, hydrochloric acid. Are you following, right? And of course, we talk about its use in manufacturing methanol. Methanol is an organic compound. In fact, methanol is the first member of the alkanol family. It is written as CH3OH. Like I promised you guys, next week, hopefully we are going to be moving on into organic chemistry. You can expand this guy. You have one carbon, 3 hydrogens directly attached to the carbon, and then one OH. So if you expand it, this is the structure of methanol, structural formula. Okay, we have talked about hydrogen being used in preparing these substances: ammonia, NH3, hydrochloric acid, HCl, and of course methanol, CH3OH. The next one is that hydrogen is used in manufacturing margarine. Margarine. Okay, hydrogen is used in manufacturing what? Margarine. To manufacture margarine, how do you use hydrogen to carry out that process of manufacturing margarine? In that case, what you try to do is to harden oil. Are you following, right? You do what? You harden oil. Oil is a bit liquid, viscous-like, but you still try to make it more harder. You still try to solidify it more. The product is margarine. Are you following, right? The product is what? Margarine, okay? Butter, what have you? So what do you do in that case? Or you just... What happens is to pass hydrogen gas through this oil, right? Through what? Oil, in the presence of nickel catalyst. In the presence of nickel catalyst. When hydrogen is passed through oil in the presence of nickel catalyst, that oil is hardened. Vegetable oil, are you following, right? Vegetable oil. So that oil is what? Hardened. That hardened product is your margarine. Okay, so you use it to produce margarine, like I mentioned. But remember, that happens in the presence of a catalyst. And the catalyst used here is nickel catalyst. The catalyst used here is nickel catalyst. Let me check on something. Seems like the video is hanging. Okay, so we are cool. We are cool to go. What is another use of hydrogen? Another use of hydrogen is in filling balloon. Using to do what? Fill balloon. The reason, because it is very light. Like I mentioned earlier, hydrogen is the lightest known metal. Hydrogen is what? The lightest known metal. For that reason, we use it to fill balloon. Remember that. We use it to fill balloon. You can also use hydrogen in the oxyhydrogen flame. You can use hydrogen in the what? Oxyhydrogen flame. This flame has a temperature of about 2000 degrees centigrade. It has a temperature of about 200 degrees centigrade, and it is used metals. It is used to do what? Melt metals. So hydrogen is used in the oxyhydrogen flame. It is used in the what? Oxyhydrogen flame. Oxyhydrogen flame. Okay? The temperature of this flame, like I said, is about 2000 degrees centigrade. So you want to take note of it. It's also a likely exam question. Yeah, the temperature of the oxyhydrogen flame and what it is used for. Oxyhydrogen flame, whose temperature is about 2000 degrees centigrade, is used for melting metals. Is that okay? Hydrogen can also be used as jet and rocket fuel. Liquid hydrogen, to be specific. Liquid hydrogen is used as rocket fuel. Can be used as rocket fuel. So you take note of that. And it can also be used to produce petrol. Hydrogen can be used to produce what? Petrol. When it is passed through coal, it produces a petrol. Now that petrol is more expensive than the normal petrol obtained from crude oil. In countries where they don't have petroleum, crude oil, and perhaps the country has coal enough. If they have enough coal, hydrogen gas can be passed through to convert that to petrol. Yes. So some countries use that. They use that process to produce what? Hydrogen. All right. So you take note of these uses of hydrogen that have been mentioned. Take note of it. And like we said, hydrogen is flammable. Just imagine the temperature that is produced when it reacts with oxygen. If hydrogen mixes with air, it's flammable. If hydrogen mixes with air, it is what? Flammable. In fact, that was the reason why when I treated tests for hydrogen, towards the end, after explaining the results, that you're going to hear a pop sound, I mentioned that you're expected to use little amount of what? Hydrogen. Yes. The pop sound you hear, it's a kind of something trying to explode. Yes. Kind of something trying to explode, because when you fix the splinter into this, why hydrogen mixes with the air that is causing burning here? Why hydrogen mixes with the air that is causing burning? When hydrogen mixes, because air there, supports that burning process. So once hydrogen meets, there's going to be a kind of flaming. Okay? So hydrogen is flammable. You want to take note of that. And whenever it mixes with air, if you're carrying out any such experiments, please make sure you're using a less amount of hydrogen gas. We are done with the uses of hydrogen. Quickly, let me state the isotopes of hydrogen. Isotopes of hydrogen, before I will draw that experimental setup that we could use to study one or two necessary things. Okay. I hope the network is still cool there, although it's cool from the device I'm using to track what is happening there. Isotopes of hydrogen. I am going to wipe the board now. Please, you can screenshot. Let me step aside a bit. You can screenshot if you have not copied that. Because I'm wiping, let us look at the isotopes of hydrogen. Isotopes of hydrogen. Isotopes of hydrogen. There are 3 isotopes of hydrogen. Yes, we have the normal hydrogen. We have the normal hydrogen, and then we have another one that looks more hydrogen in nature. We call that deuterium. We call it deuterium. And then we have the 3rd isotope of hydrogen that is called tritium. Isotopes of hydrogen. Isotopes of hydrogen. Isotopes of hydrogen. For those that are not the GMAETS 41's direct students, perhaps from our physical class, you're just connecting to this class from anywhere around the world. Remember, you can become a channel member to get access to all the video lessons available on this channel. As a matter of fact, the GMAETS 41's academic learning platform is a powerhouse learning platform for students. I repeat, it's a powerhouse learning platform for students. Come over here, your physics, your chemistry, your maths. And of course, you have another channel dedicated to English. You have a lot of things to learn from this channel. Complete works. Yes, complete works. Someone that has gone 80-90% of a particular outline is as good as complete works. So you can join the platinum level or the diamond level. The platinum level is plus minus less than $2, or highest you say $2. Okay, in Nigerian currency is 2,000 naira. And then the diamond level is less than $4, right? It's less than $4. So you can see that GMAETS 41 has really done some considerate stuff for you guys. All right. The diamond level in Nigerian currency is 4,000. You can support this channel, yeah, for the great works coming out from 41. That would be greatly appreciated. And as you support this channel, remember, you get further benefit, like I said, access to all of the materials available on this channel. Of course, you can get further assistance from GMAETS 41. Not to forget is the fact that the platinum level membership and diamond level membership is a monthly package. So once you support the channel on the platinum or diamond level, you enjoy all of the things that are available on this channel, you know, for as long as 1 month. That's a great one. Isotopes of hydrogen. Number 1, we have hydrogen itself. We have hydrogen itself. And of course, we know that hydrogen is written like this. So the mass number is 1. The atomic number of hydrogen is still 1. Are you following, right? Then the second isotope of hydrogen is deuterium. Deuterium, right? We can actually write it like this. The mass number is 2. The atomic number is still 1. Or you can write it using D. You can write it using D. So 2, 1. So either one of these, either of these is the representation of deuterium, an isotope of hydrogen, and then the next isotope of hydrogen is tritium. Tritium. And of course, it is represented as mass number 3 of hydrogen, still atomic number 1. You know, isotope or isotopy, because that's from where we get isotopes. Isotopy is a phenomenon where atoms of the same element would have the same atomic number but different what? Mass number. Atoms of the same element atoms of the same element will have different mass numbers, but the same atomic numbers. Those atoms of the same element that will have different mass numbers, those atoms themselves are called isotopes. All right, I tried boosting the network. I tried boosting the network. I tried boosting the network. Let me check. Tried boosting the network. Just be patient a bit. Network is still hanging. Just be patient. Trying to see. Trying to connect that back. The network has started messing up. Please, what is the network situation over there now? Jesse, can you indicate, is the network stable there now? Is the network stable there now? Is the network stable over there now? If the network has bounced back, you can let me know. Over there, I don't know, in this device is still disturbing. Is the network a bit okay? Can I continue? Seems like the network is still disturbing. Seems the network is still disturbing. Is the network a bit okay at that end? I need a response, please. I need a response because it seems to be hanging a bit here still. Don't know, at the time we're almost rounding off. At the time we're almost rounding off. This network has to respect itself. The network has to respect itself. I think the network is a bit okay there. Can I kick off? I need someone to indicate, is the network okay there? Yes or no? Is the network okay there? Yes or no? Indicate if the network is okay there. Still seem to be hanging somehow here. Still seem to be hanging somehow here. Please, is the network okay at your end? Let it not be that I have run out of data. So funny. The network isn't good. The network is not good. Is the network okay over there? The network seems not to be good. Could someone please tell us if the network is okay there? Well, I don't know. Here it is still hanging. It's still hanging. So the network is still hanging here. This network. I tried boosting it. Let me boost again and see. Is the network back there? Please, I need to finish up this. We are almost at the verge of rounding off. All right, I think the network is a bit okay. So let's just round off this. I was talking about if this normal hydrogen, okay, this normal hydrogen, this first isotope of hydrogen is normal hydrogen. If it reacts with oxygen, it gives you water. This deuterium, if deuterium reacts with oxygen, it will give you deuterium oxide. Deuterium oxide. You know, this is hydrogen oxide. This one is deuterium oxide. This water here is called heavy water. Heavy water. It is used in nuclear reactor. This water is used in nuclear reactor. It is used in what I said, nuclear reactor. So take notes. Your D2O is heavy water. Your D2O is heavy water. So you want to take note of that. Then if you come to tritium, tritium is radioactive. Tritium is what? Radioactive. Tritium is radioactive. So it's not easy trying to control what network does, okay? But one thing is, like I said, this is GMAETS 41. I am not affected by all these things. I'm not. And I want you to be as tough as GMAETS 41 is tough. I want you to be as tough as I am. If network is messing up, don't just easily give up. Don't. You have to work hard. It's just a matter of 1 or 2 boosting and the network will be back. So we are done with this concept of isotopes of hydrogen. Are you following? We are done with this concept of isotopes of hydrogen. We are done with this concept of isotopes of hydrogen. There was this experiment I said, no internet. There was this experiment I said I was going to have us look at. That it is an exam question. I told you it is an exam question. Sorry, I'm trying to track what happens at that end so that we will not just be wasting our time unnecessarily. I'll be teaching and nothing's happening. The network is back. Yeah. Frozen, thank you very much for letting us know. Okay, so the network is back. I could see that as well too. Let's kick off. We are done with the isotopes of hydrogen. We have our hydrogen, which is normal hydrogen. The mass number will be your interest. We have deuterium, which the mass number is 2. The tritium mass number is what? 3. And of course, like I said, isotopes are atoms of the same element. Atoms of the same element that have different mass numbers, but the same atomic number. Or atoms of the same element. Atoms of the same element that have different number of neutron. Different number of neutron, but the same proton number. You can define isotopes with respect to different mass numbers or different neutron numbers. And then with respect to the same atomic number or the same proton number. Okay? Then isotopy is the phenomenon. You use that term. The phenomenon whereby atoms of the same element have the same atomic number but different mass number. Although we are not studying isotopy and isotopy anyway, isotopy is that phenomenon. Why isotopes are the things, you know, those atoms that have different mass numbers and the same atomic number. We are done with this guy. I told you if H reacts with oxygen, you get hydrogen oxide, which is water. If this deuterium reacts with oxygen, you get deuterium oxide. This guy is called heavy water. Like I said, it is used in nuclear reactor. Are you following, right? So you want to take note. Which water is used in nuclear reactor? It is heavy water, deuterium oxide. Tritium, the third isotope of hydrogen, is radioactive. Now we're going to conclude. Are you following, right? With this diagram I'm going to show you on the board, and we are going to interpret the result, what we expect. Finish up what you have on the board. You can screenshot while we round off what is left of this class. You can screenshot while we round off what is left of this class. The network is still cool, trying to track what is happening there. Okay. Yeah, Frozen, that's the spirit. GMAETS 41. You know, once you say their network will bow. EEDC. NEPA. they will also bow. Okay? And if you are feeling sleepy, you too will also bow. Because if you hear that GMAETS 41, that sleep will get out of you. Let's move on to the last thing, please. Now, if you see this diagram in exam, how do you interpret it? If you see this diagram in your exam, how do you interpret it? So you watch, I'm going to draw this diagram. I have 2 test tubes. In fact, there are 4 test tubes altogether. So let me say I have this test tube. Okay, I have this test tube. And then this test tube that I have here, I just hope I draw something a bit good anyway. So let me say I have this test tube. And then I have another test tube that is superimposed upon it. I have another test tube that is a kind of, okay, let me say inverted. Are you following, right? Inverted. So I have this test tube, let's say it goes this way, inverted. Good. So this is another test tube. This is another test tube, something like this. And then here I have hydrogen. I have hydrogen. I have hydrogen, okay? Then here I have air. I have air. I have air. Okay, so this is hydrogen, hydrogen gas. And then this, in this test tube, you have air. Are you following, right? You have air in this test tube. Then we say that we have another setup, still something similar to this, still something similar to this. Means I have this next test tube. You have this test tube, and then another test tube inverted over it, another test tube inverted over it. Okay, something of this kind. Don't mind what I've drawn here. And then let us say that in this test tube, you have air. You have air here. You have air in this test tube. And then perhaps this test tube, you have hydrogen. You have hydrogen. You have hydrogen. Good. Now, if you have this setup and you decide, permit me to check the network situation from this end. Okay. You have this setup, and then you are asked to allow this setup for a few minutes. Let's say you allow it for a few minutes, it could be 5 minutes or less. Then you now come back. How can you prove that hydrogen is lighter than air? Please, this setup is to prove that hydrogen is lighter than air. Prove that hydrogen is lighter than air, or is less dense than air. Hydrogen is less dense than air. That is what we are trying to establish. That's what we are trying to establish. I know something, hydrogen is a gas, air is also a gas. So normally, you know what gas does? Gas can move randomly. Normally, gas does not move downward. I don't know, just in nature, gas will usually move upward. It will usually move upward. Unlike liquid, are you getting me? Liquid, you free, it always falls down under its weight. But gas will always rise up. Are you following, right? You can't see gas coming down, like it rises upward because it expands. So, these two guys can expand. Air, oxygen, or no, hydrogen rather. Now, if you come back to this setup over time, allow like 5 minutes, I said, and then you bring a lighted splint, a lighted splinter. You bring a lighted what? Splinter. What is going to happen? As you bring the lighted splinter, let us say, into this test tube. Let me call this test tube A. Let me call this test tube B. Let me call this test tube C. Let me call this test tube D. Like I said, you set up this, you have air here, and then you have hydrogen here. You know, when you fill here with hydrogen, you have to use a stopper. You have to use a cork. Are you following, right? To stopper the mouth, like to close the mouth. We actually use the term, you stopper it. Are you following, right? S-T-O-P-P-E-R. So you close the mouth so that you can now invert this test tube over it. Once you invert this test tube over this particular one, then remove the stopper. Remove the stopper. If you remove the stopper, something is going to happen. This hydrogen will rise. This hydrogen will rise. It will rise and then displace this air. It's going to push force air down. I mean, it's going to tell, hey, could you get out for me? Right? Leave this space. I am lighter than you. I am less dense than you. I should move faster. Are you following? So one could think of the concept of rate of diffusion according to Graham's law of diffusion. Remember, the lighter gases, they diffuse faster. They move faster. So it's going to move. And because it's very lighter, it's passing through the air, it will force air down. So hydrogen will displace air downward, which means the method of collecting hydrogen, we can also refer to it as downward displacement of air. Just like in our previous class, I used the terminology downward displacement of water. You can also refer to it as downward displacement of air, because hydrogen, being lighter, less dense than air, is going to push air down so that it can make its way up. So you're talking about the method of collecting hydrogen. Downward displacement of air as well. You can see that, like I said, the hydrogen goes up and then it's going to force the air down. And how do we know that this, exchange has taken place? How do we know that this exchange has taken place? The hydrogen goes up and then this air comes down. You bring a lighted splinter in this test tube B. After that, like 5 minutes, 5 minutes even too much, just a little minute, and could be 2 minutes even, because the diffusion can be a bit fast, but just for there not to be a mix-up anyway. The hydrogen gets up. If you bring a lighted splinter into test tube B, for you to know that the hydrogen has displaced air downward and hence the hydrogen has moved up, you will hear that pop sound. You will hear that pop sound. Are you following, right? Once you bring your lighted splinter into the test tube B, after some time, you hear that pop sound here. That shows that hydrogen is present in this B. Are you following, right? That shows that hydrogen is what? Present in B. Are you getting? Now, if you fix the same lighted splinter into A, if you insert the same lighted splinter into A after that time, you will not hear any pop sound. You will not hear any pop sound. It's possible the lighted splinter might still be burning because you now have air here. You now have air. You won't hear any pop sound. Like I say, air is now coming down, and then here, hydrogen goes up. Hydrogen goes up. So this is H2. There's going to be that exchange. If you insert that lighted splinter into this test tube A, you won't hear any pop sound after that sometimes, because the air has displaced that hydrogen, right? Or the hydrogen rather has displaced air. Like I said, hydrogen moves up, displaces air downward. Are you following, right? So air gets down to test tube A while hydrogen moves to test tube B. So while you insert the lighted splinter into test tube B, you will hear pop. But if you insert it in test tube A, there will be no pop sound, telling you that hydrogen has been removed from that test tube A. Are we together? Then if you come to this, remember that the hydrogen is already up. Like I told you, generally gases wouldn't move down normally. Yeah, they wouldn't. Although since both of these guys are gases per se, it now depends on their weight, their density, so to say. It depends on their what? Density. So it is expected that the one that is less dense will be on top. The one that is denser will be under. So if air is already here in test tube D and hydrogen is already up in test tube C, hydrogen is lighter than air. You don't expect this hydrogen to displace downward, to move downward. It can't. Rather, it will be trying to find its way up. So in this case, what do you expect? If you bring your lightest splinter after some times, if you bring your lighted splinter into this test tube D, the lighted splinter will just be burning. It will just be burning. Are you following, right? Because of the air there. It will just be burning. There will be no pop sound. There will be no what? Pop sound. So you want to take note of that. There will be no what? Pop sound. The reason is because hydrogen is not here. This hydrogen cannot. And that is why I'm not drawing any arrow movement. I'm not drawing anything like that there. Because it's not, there wouldn't be any exchange here. There wouldn't be any exchange. Then if you insert the lightest splinter here, that lightest splinter will burn with a pale blue flame. It will burn with what? A pale blue flame around the ring. Around what? The ring, somewhere here. So it burn with a pale, because the hydrogen will saturate this place, you know. It's going to burn with a pale blue flame. Because this air also will try to rise, but the air cannot displace this hydrogen down. So somewhere around here, it's going to be burning. Are you following? The lighted splinter, once you insert it, as you're inserting the lighted splinter here, you won't hear anything like pop sound per se, even if hydrogen is there. The reason is because this air, yes, will try to rise up to this point, the rim part, the mouth part. Are you following? But because this air cannot push this hydrogen down, it will still remain that way. The lighted splinter will burn with a pale blue flame here. Now, if you move the lighted splinter further into this test tube inside, all right, so I think the network situation is a bit down, but like I said, we are done. I was trying to explain, if you insert a glowing splint here, take note, like I said, the hydrogen will try to be coming down because it will have to find an escape route to escape. Since this test tube is not open there, assuming the test tube is open there, the hydrogen will escape upward to be going to wherever it wants to go to. But since it's not open here, usually it will tend to occupy all this space here. So it will move down somehow, but this air also will try to like rise up. But when they meet around this ring, the mouth part, are you following? They cannot exchange like they exchanged here. The reason, you have a lighter gas on top. Air is heavier than hydrogen. So at this point, they'll just be there. Are you following, right? Moving like this. So you have hydrogen around here, you have air around here. If you put your lighted splinter inside this test tube D, the lighted splinter will be burning, Are you following, right? Because of the air. If you insert the lighted splinter into test tube C, around this rim, this part, the lighted splinter will be burning with blue flame because you have hydrogen around here. But you may not hear that pop sound yet. Are you following? You may not hear it due to the fact that there is a kind of mixture of air and oxygen somehow. Are you following, right? Or rather, there is a kind of interplay of hydrogen and air here. But of course, you know that the air has not entered this test tube. The air does not have a way to move into this test tube. So since the air can't move into this test tube, hydrogen and the air cannot mix. Hydrogen and the air cannot do what? Mix. So if the lighted splinter is here, the lighted splinter will only be glowing with blue flame. You won't hear the pop sound because there is no air mixture there. You won't hear any pop sound because there is no air mixture. The hydrogen will be on top floating once the lighted splinter is somewhere here. But then if you move the lighted splinter further inside, remember that the hydrogen had moved down. No hydrogen here again, no air. Automatically the lighted splinter, the flame, will be extinguished. once it moves deeper into test tube C. So that is it. I would like to write here that in this part, lighted splinter bonds. Lighted splinter bonds because of air. Because of air presence or presence of air. Because of presence of air. Let me adjust the camera a bit so it doesn't cut off. We are almost done, please. You just got to be patient. All of your names should change to patience now. Patience, endurance. Your name should change to patience, endurance. Because of presence of air. Then here, if you insert a lighted splinter, somehow this way, okay, all right, lighted splinter burns. Lighted splinter burns with blue flame. Because of hydrogen. Because of hydrogen gas. Now, if the lighted splinter move further, say somewhere here, the lighted splinter flame is extinguished. That is put off because of absence. Because of absence of hydrogen gas and air. No air here, no hydrogen gas, because the hydrogen has moved to this portion. Okay, let me do something. Some hydrogens will come to this portion. I'm going to show the hydrogen coming down here, but it can't enter this test tube. That's just the whole thing. And I think with this, you're actually done with what you are meant to hear. Remember, in this case, or what you're meant to know, in this case, there's no pop sound. Here, there is pop sound. Once the hydrogen moves down, so the hydrogen moves up, air moves down. In test tube B, you hear that pop sound. Okay, so, but sir, air contains hydrogen. How can hydrogen be less denser than air? Sorry if you find this stupid. Well, your question is not stupid. It's not stupid. Your question is very reasonable. Are you following, right? It's very reasonable. Now, from what you said here, Prerna Kushagra, I think from India. Now, from which country? This class is streaming from Nigeria. Okay, now, air contains hydrogen. You are very correct about that. Air contains hydrogen. But remember that hydrogen is not the only component of air. As a matter of fact, even the composition of hydrogen in air is quite small. It's quite small. Are you getting me right? It's quite small. And you said that how can it be said that hydrogen is less dense than air? Remember, in air is a mixture. Air is a mixture. It is not uniquely one gas. It is not. We are not looking at if you extract your hydrogen, you have hydrogen on its own, and then have a mixture. You know, if you come to air, you cannot say that air is hydrogen. You cannot say that air is oxygen per se. You cannot say that air is nitrogen per se, although the highest composition of air is nitrogen, I guess, right? I think 78%. Then oxygen is 21%. You now have something like carbon dioxide, water vapor, and the rest. So air is a mixture. It's a mixture. Hydrogen is a gas on its own, just that component, hydrogen alone. So if you look at air being a mixture and you now have hydrogen alone, what does that tell you? Definitely hydrogen will be lesser. If I use the terminology weight, hydrogen will have lesser weight than that air. Are you following, right? So take note of that, please. Air is heavier than hydrogen, is denser than hydrogen. So friends, this is how we come to the conclusion of hydrogen and its compound. In our next we'll be looking at chlorine and its compound. And then our next class will definitely be this week. However, tomorrow we are giving attention to physics. Tomorrow we're going to be rounding off our sound wave. Make sure you're prepared. By God's grace, we're going to deal with sound wave. Are you following right? Then to the GMAETS 41 physical class students, all right, remember I'll be meeting you friends tomorrow. By 9 o'clock, you have biology with your biology teacher. And of course, I will step in as usual by 11:30 for your physics. Be prepared, please. You can discuss with your sponsors and parents. Let them know, because tomorrow, your class is still closing, physical class by 4 p.m. Please take note. Physics. We're going to be looking at the concept of heat energy, right? Effect of heat, where we study linear expansivity, that is thermal expansivity, linear area and volume expansivity. We are going to move on into the concept of heat capacity, where we'll also study specific heat capacity. We'll study latent heat of fusion and latent heat of vaporization. Are you following right? Latent heat of fusion of ice, latent heat of vaporization of steam. We're going to deal with all of those concepts tomorrow. So make sure you get prepared and come with your food. You can bring food for me too anyway. All right. Is hydrogen filled balloon air? Yeah, hydrogen is used in filling balloon. We've discussed that as a under uses of hydrogen. I explained that hydrogen is used in filling balloon. Okay. So you are trying to explain the concept of buoyancy. Well, if that is how you refer to it, I would say yes, no, somehow, because the term buoyancy is usually applied to liquid to be much more specific. But to buoy, for something to buoy, is much like the thing has a floating ability. So, well, if that is the terminology you want to use, I usually use the concept of buoyancy for fluid mechanic study. Are you following right? Under engineering. But if that is what you want to use to understand the fact that hydrogen is less dense than air, meaning it can buoy on top of air, it can float on top of it, good. It's cool, okay? Still cool, just like a rule of thumb for you to remember. Please, we are closing this class now, and I was supposed to have, a past question review class, but all the same, let's see how it goes. We can't do it tonight again. But there is just this question that I have here. Perhaps let me dictate it. 1995 JAMB, question 34. In the industrial production of hydrogen, from natural gas. Our natural gas, anytime you hear it, please, methane should come to your mind. Our natural gas, anytime you hear of it, what should come to your mind? I said methane, CH4. So start thinking of the industrial preparation of hydrogen, not from the Bosch process, but from methane. That is from natural gas. Now I read the question. In the industrial production of hydrogen from natural gas, carbon dioxide produced along with the hydrogen is removed by, carbon dioxide that is produced along with the hydrogen is removed by, remember, both in the Bosch process and in the methane or natural gas process, in the second stage of the reaction, you will react either the water gas from the Bosch process or the synthesis gas from the natural gas or methane process. You react the excess, as you react the synthesis gas in this case, because we're talking of natural gas, you react the synthesis gas, that is CO plus 3H2. You react it with excess steam. Now the examiner is asking you, the carbon dioxide that is produced then, if you react CO plus 3H2 with excess steam, we explain that it's going to give you carbon dioxide. This CO will pick oxygen here, carbon dioxide, and then this hydrogen and this will react. This hydrogen and this will react. And of course, if they react, you're going to be getting 4H2 gas. So this carbon dioxide, how do you remove it? That is what the examiner is asking you. We treated it in our last class, okay? A, washing under pressure. B, passing the mixture into the lime water. C, using ammoniacal copper 1 chloride. D, drying over phosphorus 5 oxide. The correct answer is dissolving or washing the carbon 4 oxide under pressure. I remember mentioning that you can dissolve that carbon 4 oxide under a pressure of 30 atmosphere in our previous class. So the correct option would be option A, washing under pressure. You wash the carbon 4 oxide under pressure in order to remove it. Now, there is this option mentioned here, option C, using ammoniacal copper 1 chloride. You use ammoniacal copper 1 chloride or maybe copper 1 ethanoate, as the case might be, the ammoniacal solution to remove carbon 2 oxide, any remnant of that carbon 2 oxide. Okay, now 2016 question. 2016 question. 2016 question. That 2016 question, we have this, and the question is, that's question 29. It reads, the gas that produces a pop sound when in contact with flame. The gas that produces a pop sound when in contact with flame is option A, nitrogen, option B, sulfur, option C, hydrogen, option D, oxygen. We just discussed that. And of course, the correct answer is hydrogen, hydrogen gas. Are you following right? Hydrogen gas produces pop sound. Okay, now can somebody drop the answer to this question? Can somebody drop the answer to this question? Okay, this is 1999 JAMB question, and it reads, hydrogen is used in oxyhydrogen flames for melting metals because hydrogen is used in oxyhydrogen flames for melting metals because option A, evolves a lot of heat when burned. Option B, combines explosively with oxygen. Option C is a very light gas. Option D is a rocket fuel. The question is, hydrogen is used in oxyhydrogen flames for melting metals because, so why do we use hydrogen in the oxyhydrogen flame for melting metals? What is the reason? Option A, evolves a lot of heat. Option B, okay, evolves a lot of heat when burned. That is option A. Option B, combines explosively with oxygen. Option C is a very light gas. Then option D is a rocket fuel. What is your answer? Drop it in the comment section. I taught that concept. I explained it. In the oxyhydrogen flame, I told you the temperature is about 2000 degrees centigrade. So why is it that we use it for melting metals? Why do you use hydrogen in the oxyhydrogen flame for melting metal? What's the reason? Drop the answer in the comment box. And of course, I would say it much later. We are done with our class tonight. And be seeing you guys tomorrow in our physics. Okay? Good night, friends. Go and take your rest now. Let's sleep for another day tomorrow. Okay, Rejoice, you dropped an answer. You said it's B. Let me read out the options again. A, evolves a lot of heat when burned. B, combines explosively with oxygen. So the B you went for is combines explosively with oxygen. Is that the reason it is used in the oxyhydrogen flame for melting metals? You cannot think of a situation where something combines explosively. An explosive process does not yield any reasonable thing, because when there is explosion, it can be deadly. Explosion can be deadly. So if we go for option B, combines explosively with oxygen, something that's explosive, can you actually harness it? Though it's possible to be harnessed, but or is it because it produces high heat? So think about it and come up again with what the correct option should be. Are you following right? Think of it and come up with what the correct option should be. All right, Mary Frances Mweke, you said it evolves a lot of heat when burned. Good. Okay, let's see. Chinedu, you're asking, sir, options. All right. Option A, evolves. The question first is, hydrogen is used in oxyhydrogen flames for melting metals because, so what is the reason why hydrogen is used in the oxyhydrogen flame for melting metal? Why do we use it? Option A, evolves a lot of heat when burned. Option B, combines explosively with oxygen. Option C, is a very light gas. Option D, is a rocket fuel. So what do you say is your answer? Mary Frances said it evolves a lot of heat when burned. I think I agree with him, or with her rather. And then Chinedu again, you went for option A. I agree with you. Ruth Norman, PG4JE, correct your English. I'm not in English class, so I'm going to correct nothing about it. Okay, we are done. Good. Prince, it good. Prince, it produces a lot of heat. And that's the correct option. That is the correct option. That is the correct option. So we are done with our class, and the majority of you went for option A. That is actually the reason why we use hydrogen in the oxyhydrogen flame. Once that reaction proceeds, a lot of heat is produced, and that heat is used in melting. It's used in melting metals. Remember, I told you the temperature is there about 2000 degrees centigrade. All right, friends, please think. Let's close the class now. It's been a wonderful one. I'll be seeing you tomorrow. Like I said, please get your good rest and prepare for tomorrow's physical class, after which we're going to meet tonight, tomorrow,